Level up.
Go ahead.
Complex numbers.
Thank you.
Period.
All right, last week. I don't remember what day it was.
I think it is.
Monday.
We talked about, yes, or maybe.
No, we weren't here Monday.
No. Okay, so anyway, we were solving by graphing, right? Robert, shh, guys. And we had 3 scenarios. Scenario 1 was it had 2 solutions because it crossed the x-axis in 2 places. Scenario number 2 was it had 1 solution because it crossed the x-axis 1 place. What was scenario 3?
No
solution, right? It looked like this or like this. I didn't do any of them that opened down, but they could open down, okay? So what we're going to do, we've talked a good bit about the first 2 scenarios. We're going to talk about what happens in this scenario and how that occurs and why that occurs, okay? So to understand that, we have to understand, Robert, put that up.
How do you get one that goes sideways?
It's not a parabola.
It's not like it's
It's the inverse. It's the inverse. It's a square root graph, but it doesn't include the bottom part because it would be, yes, correct. All right, but we will get to all that. All right, so I want to talk to you for just a minute, and then I'm going to pull everything back to those graphs that I started with. Imaginary numbers. If I have what's wrong with that? Can't have a negative under the radical, right? We all know that. You've learned that a long time ago. That's been a rule since forever. So, we invented imaginary numbers to handle that. Okay? What an imaginary number is, we use this little variable I. Imaginary, right? That makes sense. And we let that be the square root of -1. Okay? So now think about this for just a minute. We know these properties of radicals because we've simplified radicals that I could rewrite this and tell me if this is true or false. The square root of -2 could be written as the square root of -1 times the square root of 2. Do you agree or disagree? Yes, because I can break them apart that way, right? We know that that little property of radicals, this is the same thing as this, right? Come on, guys. We have simplified radicals where if we had the square root of 50, we could say that's the same thing as 25 and 2, which is 5 square root of 2, right?
Yes.
So now, if I let I be the square root of -1, I can get that negative out, and this is just going to become I times the square root of 2. I'm still going to do my plus or minus because I'm still talking about a radical here with 2 solutions. Okay? So, every time you see a negative under the radical, simple version, drop the negative and put an I out front.
All right.
Okay? So let's look at what happens with these.
Look down a little bit.
What?
I look down for like a few seconds.
That's because you're looking down at something that's not math, Dylan.
Well, you see, this is due next.
Oh.
And I cannot fit these words into a crossword.
Let's say I have the square root of -4. This one is a little different because it is a perfect square, right? But the same process. The negative is under the radical. I'm going to put an I in its place. And what is now, I can go through my simplification process the same way I do. So 2, exactly. I'm going to do plus or minus out front, 2. And I'm going to put the I after. That's just good, pretty math. It comes before the radical or after a coefficient.
Do you put the plus and minus in front of the after?
You always want to put it in front, and that's a really good question. And the reason is, if I did it like this, my value has now changed. Here I'm 2 times I. Now here I'm being 2 plus I. So you want it in front of the multiplication.
What about before 4? Like,
Again, if you did it there, if you did it like this, that would be saying I plus the square root of 4 instead of times. And this is times. The value of I is the square root of -1. Always. Absolutely.
Well, let's do one.
That's
You're the hard
easy. Is
one.
that all the good?
Let me show, no. This is about a quarter of what I got to show you. All right, let's say I have negative 27 under here. And before I set you loose to do one on your own, let me at least show you one like this where we break it apart, okay? Remember when we simplify radicals, we're looking for the biggest perfect square that we can divide it by, right? So the first thing I see here is the negative. I'm just going to go ahead and pull that out to start with, so I don't even have to pay it any attention right now until I'm just going to carry it on down, okay? What is the biggest perfect square I can divide 27 by?
9.
9 times what?
3.
Do we all agree with this?
Yes. And then third is 9.
Square root of 9 is 3. I'm going to put the I here and then do square root of 3. I want my plus or minus to go in front of any multiplication
So in that,
happening.
in that instance, doesn't matter where the I goes.
That is simplified. Just nice, pretty math. It's going to go behind a whole number. It's going to go in front of a radical.
What do you do with negative for, you put it before the 9?
Do what now?
The negative? Do you have to put it before the 9 or the 3?
What negative?
For negative 27.
You get rid of the negative with the I.
Yeah. Let me ask you this. Thank you. If I is the square root of negative 1,
You skip a classroom, skip the level.
what do you think I squared would be?
I squared would be negative 2. Squared.
I get ready to get.
I don't know, it'd be negative 1, negative 1. I don't know.
1. I.
Haven't heard it yet.
What?
Let me ask you this. Somebody said it. I think it might have been negative 1. Here is why. Here is why. What is the opposite or what is the inverse operation of square root? In other words, what cancels out a square root?
Multiplication.
Exponent of 2. Do we all agree that if you have these two things together, they cancel out?
Of course.
They're opposites. So if I is the square root of negative 1 and I square it for I squared, then I'm left with negative 1. Okay, take this a step further. What then do you think I cubed might be?
Oh, that.
Negative 1 over 3.
Whoa,
Negative
we got there fast.
I'm guessing.
Negative 1 for the first.
Negative.
It's 1
Is it
times
1
the
over
square root of negative 1.
All right, take the 1 before it and multiply it by another I. If I take the 1 before it and I multiply it by another I, so another square root of negative 1, this is I, right? It's just negative I. You're going to have to do iterations like this on your homework. That's why I'm running through some of them.
Do we have to explain why?
How about I to the 4th?
So we can just write negative 1.
No, positive I.
Positive 9.
I to the 4th is squaring which one?
Wait.
Are we guessing?
Wait.
What would the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1 be?
Negative 1.
Positive 1.
Did I
You're
not
exactly
say
right.
that?
I don't know. I didn't.
I
hear you.
literally said positive.
Hey, it's too good.
Positive
I
1.
didn't say anything.
Is that the same thing as just I?
Please sit down.
Okay, here's what happens if this is positive 1. Guess what happens?
First with the top, I don't know.
It all starts
Oh,
over.
hey, I got that one.
It all starts over. So this, which was just I to the 5th is just I as well.
Is it I or is it 1?
Oh, wow.
Square root of negative 1. Or I, same thing. This is positive 1. This is I. There is a chart in your book on page 172 that goes up through iteration 8, but these would just start repeating. Like this is I to the 5th.
I just don't.
This
think
is
that.
I to the 6th. This is I to the 7th. This is I to the 8th.
Ain't no way.
This is I to the 9th. I to the 10th. You still don't see the pattern?
I see it.
Ain't no way.
Guess what it starts back at?
13.
Right.
And then 17.
Okay.
And then
Yeah.
So 100.
Okay.
So I5. Oh, it's at the beginning.
Yes. So it's on a constant loop with those four values. I raised to any power is either going to be I, -1, -I, or +1. It's going to be one of those four values. All right, let's keep it moving with some imaginary. Let me get you to simplify one, and then we're going to move on to the next concept here with eyes. Remember, the title of this lesson was complex numbers, not imaginary numbers. So stay with me.
There's more.
There's more.
Yay.
Simplify this.
Okay.
Dang it, can you go back to the chart?
You don't need the chart for this one.
You might.
That was just a little side note there for you.
This was easy. I don't know how. Just stop turning that down.
What'd you take out?
-5.
5.
25 and 5.
25 and 5. Square root of 25 is,
5.
so I got 5I root 5.
You got that plus my 8.
That's all we needed to do?
Oh.
Simplify this one.
This will be like, I don't know what you have to do.
Is it a reverse? Are we just reversing it?
A little bit. What might this become?
15?
How'd you know?
You can reverse it?
-5 times 3 is -15. I times I is I squared. I know. I squared is,
-1.
so -15 times -1, Robert was absolutely right, is +15.
You heard me this time.
I did.
First of all, close your legs.
Good job, Robert. What?
Oh, it's over.
Look at this one. This one gets, you gotta think about this one a little bit more.
It was a hard one. Oh, gosh.
Bless you. Square root of -1.
Miss Minnie, so you know that song G6?
So simplify each radical individually first, and then start putting them together. Because if you multiply them together under the radical first, you're going to get a negative times a negative, which is a positive. It's not working because of our plus or minuses that we have to do with radicals. So simplify each one on its own first. In other words, this,
Is 3 and -3.
well, neither one of those are perfect squares. Just take the negatives out and make them I.
Oh, gosh. Wait, don't we combine like terms?
Well, you're not adding. So you multiply under that radical. What's 6 times 15?
90.
All right, so I times I is I squared. And we know that I squared just does what? Turns into what? -1. So I've got -1. What's your perfect square coming out of 90?
15. Wait, no. Sorry. I needed that.
9 and 10. So I got 9 and I have 10. I have -3 times the square root of 10.
Robert.
Wait, can you split 5 and 2?
So wait, this is all.
No, because 5 or 2 is not a perfect square.
So we don't need graphing over this?
Huh? There's no graph.
Oh, the I
what'd you
turned
say?
into a negative.
Oh, we don't need the plus or minus, I'm sorry. No wonder y'all are looking at me, because it's forcing the
So
negative.
when we get this little
All right,
chart,
listen.
when we get a little chart.
Wait, why did you say not 5 and 2?
So you have to remember that's like vocabulary?
You only have to remember 4, and then they
That's
start
crazy.
repeating. All right, look, shh, not done.
Sorry.
Not 5 and 2, because 5's not a perfect square and 2's not a perfect square. When you split them, you need at least one of them to be a perfect square.
Wow.
All right, because that's how you simplify. Solve for x. Do it now. Do it now. Solve it for x. What are the solutions?
Wait.
Don't say it out loud. Don't say it out loud.
Renegade.
Stop saying that.
Miss Minnie was caught.
How do you do that? That's a good question,
Don't tell us what
Coffin.
you do.
Yeah, I need to explain it for him.
It doesn't show up on my calculator.
If you do the calculator, you are going to get something that looks like
Did
this.
you graph it?
Wait.
No.
It's a,
Solve it algebraically. How do you get x by itself?
is it the square root of
Minus
64?
64.
How do you do that? I forgot.
How do you get rid of an exponent Cawthon forgot?
Square root.
What's the inverse?
Square root of 64.
Square root.
That's what I was,
So then it could be
So
8.
you're right, square root, but here is where now you see why this is
It's
pertinent to this
eight,
section now.
It's
Is it 8?
Yes.
No, it's not.
I think.
It's an I. It's a negative 64. So it's plus or minus 8I. Do not forget to take that negative out. You can't do the square root of a negative number. So this becomes I times the square root of 64, and then the square root of 64 is 8.
That's cute. I
Okay.
think I remember this.
We put I before the number, will that take points
So
off?
what's this?
You see Anna's boyfriend?
Then what's?
RBI